Arithmetic sequences. What are they and how do I find a formula for them? Well, that's what we're going to learn in this video. So let's just dive right into it. Now, hopefully, before you watch this video, you know what a sequence is. If not, I'd recommend going back and watching another video I have, Sequences Explained Simply. But let's dive into what an arithmetic sequence is. Basically, it's a certain type of sequence. So in an arithmetic sequence, here's what we have. Successive terms in an arithmetic sequence have a common difference or a constant rate of change. So the biggest thing that makes an arithmetic sequence is that there's a common difference from term to term. So successive terms have a common difference. So an arithmetic sequence is a specific sequence where a linear pattern exists, because this should sound familiar. A constant rate of change? Oh yeah, that is a linear function. So an arithmetic sequence is simply nothing more than a linear function. And remember, if you watch the video on sequences, a function is a sequence is a function. The only change is that the input value could only be a whole number, 1, 2, 3, 4, 5, 6, 7, 8, so forth. So pretty simple ideas here. So let's just kind of make one up real quick. So again, successive terms have to have the same common difference. So maybe we see 6, up 4, 10, up 4, 14, up 4, 18, up 4, 22. That would be an arithmetic sequence because we have a constant rate of change. Up 4, up 4, up 4, up 4, up 4. Any two consecutive terms, the difference between them is 4. 10 minus 6, 4. 14 minus 10, 4. 18 minus 14, 4. So that's it. I mean, that's how simple it is. So the rate of change doesn't change. The rate of change is 4. It stays 4. And it's consistent and constant. So yes, arithmetic sequences are nothing more than linear functions with the only difference that the inputs have to be positive whole numbers. So if I plug in 1, I get 6. Plug in 2, I get 10. Plug in 3, I get 14. Plug in 5, I get 18. Can't plug in 1.7. You can in a function, but not in a sequential function. So let's dive into some more specific examples. All right, here's one here, 3, 10, 17, 24, 31, 38. What is the constant rate of change? Well, all you got to do is subtract two consecutive terms. You'll find it. 10 minus 3, 7. 17 minus 10, 7. 24 minus 17, 7. So my common difference is positive 7. The rate of change is up 7. So simple. All right, how about this one? Let's see here. This one is going down, but that's allowed. That's a constant rate of change. Instead of going down, instead of going up, it can go down. So let's see here. 3 minus 5, negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. Negative 3 minus negative 1, negative 2. We see a constant difference, a constant rate of change of down 2, down 2, down 2. Pretty simple. Now here's another one with decimals. Remember, you can only plug in a whole number. So the first term creates a 6.3. Second term creates an 8.1. But the outputs are still allowed to be anything, decimals, fractions, whatever. Now here, we got to be careful because sometimes for students, it's harder to see what that common difference is when you're working with decimals. Most people look at that first example and say, oh yeah, I'm adding 7. Or even the second example, I'm subtracting 2. But here, listen, do not be afraid. Grab a calculator. If it's arithmetic, it has a common difference between any two consecutive terms. So 8.1 minus 6.3, that's a common difference of 1.8. Then just make sure it's still available. 9.9 minus 8.1. Again, I'm checking successive terms. Another up 1.8. 11.7 minus 9.9. Hey, what do you notice? 1.8. So here my common difference is 1.8. It's a constant rate of change going up 1.8, up 1.8, up 1.8, up 1.8. And the last one we have here is with fractions. So again, whole numbers, it's easy. Plus 7, plus 7, plus 7. But with fractions and decimals, sometimes it's a little bit harder to see what that constant rate of change is. So just subtract, find the difference between any two consecutive terms. So 22 fifths minus 2 fifths is a difference of 4. Up 4. 42 fifths. Subtract 22 fifths, a difference of 4. I'm adding 4. And you can even look at that common difference of 4 as 20 fifths. That actually might make it a little bit easier to see. 2 fifths plus 20 fifths is 22 fifths. Plus another 20 fifths, 42 fifths. Plus another 20 fifths, 62/5. So you do see how the common difference is 4, but instead of being a just whole number 4, it's a fraction 25ths, but it's still 4. So these are all examples of arithmetic sequences where we are changing at a constant rate that never changes. That's the whole idea of why it's called a constant rate. All right, now the next thing we would like to be able to do is find a formula for that nth term. What is the nth term? Well, it's a formula to find any term you want. Get it? Any term you want. Any term, right? Okay, so keep in mind, this is no different than a function. You plug something in, you get something out. But, can't say it enough, the only difference is I'm only allowed to plug in whole numbers, starting with 1, then 2, then 3, then 4. That's what makes it a sequential function. So this right here is the formula for the nth term of an arithmetic sequence. Now, a couple things I want to point out here. The common difference needs to be found first, and we just practiced finding it in 4 examples. It's the number that you are constantly changing by. And the other thing I want to point out is there's always going to be an n, right? N is the term number you're trying to find. So n is like your x, right? You know, functions, x goes in, y comes out. Well, with sequences, we usually use an n. So n goes in, the term for that value comes out, right? Plug in 1, you get the first term. Plug in 2, you get the second term. Plug in 3, you get the third term. So again, n is the variable that is going to stay. So the big question is what is this a sub k and what is this k? Well, basically that is any term you want it to be. That is the kth term. Okay, so I know this is going to be a little confusing. It's the only thing that we're going to have to really kind of clarify here. But basically, k and a sub k is one of my inputs and outputs. So k is a term and a sub k is the term's value. And this is where you have freedom to use any term I want. So if I want to use a 1 for k, that's fine, but I just need to know what the first term is. That would be a sub k. Or I could use 5 for k, no big deal, I just need to know what the 5th term is. Or I could use 7 for k, but then I would just need to know what the 7th term is. So again, common difference d, that's pretty straightforward. That's the difference that your sequence is changing by at a constant rate. N is going to stay n because that's the whole point of a function. There's got to be a variable in there. And then k and a sub k, it's like a point, right? Think about, right? We just got done saying that arithmetic sequences are linear, and a linear functions create points, x comma y. So that's exactly what this is. K is the input, that's a term, and a sub k is the value of that term. So this would be like my x and my y. And it doesn't matter what you just use, you need a point. It's actually very similar to, actually, let's think about this for a second. This is going to blow your mind. Get ready for this. Hopefully everybody knows what's called point-slope formula. Point-slope formula is how you can find the equation of a linear line, okay? And if you remember, here it is. It's f of x minus a particular y value, just called yi. It's just like an individual y, equals the slope times x minus the individual x value. So once again, let's kind of focus here. What's m? That's your rate of change. Well, that's all I'm calling that is d. I'm just using a different letter for it. And then we have x. X is just the input value. That's like my n, right? It's just, functions called x, sequences called n, but who cares, right? But the last piece is that this xi and this yi are the same thing as k and a sub k. It's just an input x and an output y. And it's any one you want, any input value, any output value from that input value. Now, you might say, well, wait a minute, this looks a little bit different, but check this out. If we add the yi over, again, that's just an individual y, we get that the linear function is the individual y plus m times x minus xi. Hey, that is the same exact thing, right? There's my rate of change, that's my d. There's my variable, that's my n. And then we have a single point. Doesn't matter what point, just need one of them. Input, output. That's the same thing as k and a sub k. K is just the input, the term number. A sub k is the output or the term value for that term. All right, so the point I'm trying to make is this formula might look a little bit weird, but it's actually a formula we're already very familiar with. It's point-slope formula. All you need is a slope, aka the rate of change, d, and you need a point. In this terms of a sequence, that's the term and the term's value. All right, enough talking about the formula. Let's actually go ahead and use it. So here is a sequence, and we first recognize it's arithmetic. We're going up 7, up 7, up 7, so we know my common difference is 7. Now all we got to do is create the equation. So once you have your common difference, the only other thing you need, just like thinking about a linear line, is you need a point. Doesn't matter which one, right? I actually got 6 options up here. This is the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. I just need one of them. So let's go ahead and use the fact that the third term is 17. Input, that's my k. Input is the term, 3. The output for the third term is 17. So again, this is no different than point-slope form. So here I go. My term, or my formula for any term, is the output for my point, 17, a sub k, plus the common difference, 7, times n. I almost wrote an x. But right, I mean, would it matter if I did write an x? No, it's an input value. We typically use n when it's sequence, minus the particular term value, which is 3. So once again, there's my rate of change. There's my variable that stays n. And then the 3 and the 17 are just one of the points that I chose to use. I could have chosen 1 and 3, 2 and 10, 4 and 24, 5 and 31, 6 and 38. You could even choose more if you wanted to. All you need to know is what term you're using and its value. All right, then all we got to do is clean this up here. So we got to distribute that 7n minus 21. Combine my like terms, and I get 7n. Let's see here, 17 minus 21 is negative 4. So now I have a formula to find any term I want. It's always worth it to make sure it works. Let's just check that if I plug in 6, I do in fact get a 38. 7 times 6 is 42. 42 minus 4 is 38. Oh my gosh, the formula works. And I can't emphasize enough. I chose 3 and 17. I could have chosen any one of these other values and I would have gotten the exact same answer. All right, let's do another one. All right, once again, first I got to confirm this arithmetic by realizing that there is a common difference, down 2, down 2, down 2. So there's my common difference of negative 2. Then I simply need one point. Doesn't matter which one. First term is 5, second term is 3, third term is 1, fourth term is negative 1, fifth term, sixth term, seventh term. It doesn't matter which one you use. I'm going to go with this one right here just to show you that you could pick any one you want. So input is 6, output is negative 5. That's the k I chose. It's just any term and its corresponding term value. All right, so here I go building this formula, nice and easy. A formula for any term I want is going to be negative 5. That's the output of the point I picked, plus negative 2, that's my common difference, times n minus 6. Once again, rate of change, variable. And then the 6 and the negative 5 is the input and the output from the point that I chose to use. Then all I got to do is clean this bad boy up, distribute. I get a negative 2n and a positive 12. Combining like terms, I get negative 2n plus 7. Negative 5 and 12 makes a 7. And again, don't ever be afraid to check and make sure it works. If I plug in 4, I need to be able to get negative 1. That's going to be negative 8 plus 7 is negative 1. That does confirm that the formula works. All right, let's try it with this one with even decimals. It still works with decimals. So remember, first confirm that this is an arithmetic sequence. It goes up 1.8, up 1.8, up 1.8. Again, with fraction or with decimals and fractions, it's a little bit harder to see that common difference. So just subtract any two consecutive terms and proves that it's 1.8. So there's my difference. First term, second term, third term, fourth term, fifth term. You just need one of them. Now, you know what? I'm going to be honest. A lot of people find it convenient to always use the first term. Like, I'm not saying you have to, but it does make sense. It is convenient to always use that first term. 1, 6.3. And most people use the first term because it's a lot easier to work with number 1. But listen, if you're good at working with numbers, what's it matter? So once again, a formula to find any term you want is going to be the output of the point we picked, 6.3, plus the common difference of 1.8 times n minus the input value. So again, this is my k, and this is my a sub k. It just doesn't matter which one you pick. I picked the first term, which is 6.3. Could have picked any of them. And let's go through it. 6.3 plus distribute 1.8n minus 1.8. Combine my terms here, the 1.n, and then 6.3 minus 1.8 is positive 4.5. And I can't say it enough. Just check and make sure it works. Plug in 5. 1.8 times 5 plus 4.5 does give me 13.5. So it does show that the formula does work to produce any term I want. And the cool thing is, once you have this formula, if I want to find the 100th term, all I got to do is plug in 100. Boom, get my answer. Easy as that. All right, let's try a fraction one here. So we saw this one earlier as well. So remember, we're adding 4 25ths, adding 4 25ths, adding 4 25ths. So my common difference is 4. And then I just got to pick the first, the second, the third, or the fourth term. I'm going to go ahead and knock myself out and use the fourth term right there. It's going to be super fun. Watch. All right, a formula to find any term I want is going to be the output, 62 over 4, for that value I picked, plus the common difference of 4 times n minus 4. That was the value that led to the 62 force. And then I just got to do a little bit of cleanup work. 62 force plus 4n minus 16. And let's see here. So I get a 4n. Grab a calculator if you need to, or if you're really good at fractions, you could say, oh, wait a minute. I know that 16 is no different than 64 force. So 62 minus 64 force is negative 2 force, which is, well, negative 1/2. So a formula would be 4n minus 1/2. There we go. And then again, please check and make sure it works. Plug in 2. I get 4 times 2 minus 1/2. That's 8 minus 1/2. And 8 is 16 halves. 16 halves. Minus 1/2. Wait a minute, that's not working out right. What did I do? Let me go back and check my work here. Okay, so 16 is 64 force. 62 minus 64 force is negative 2 force. That's negative 1/2. 4 times 2 is 8. 8 is 16 halves. 16 halves minus 1/2. Let's see here. That's going to be 15 halves. Let's see. I got to make a mistake somewhere. And I see what my issue is. Oh my gosh, this should be a 62 fifths. What's wrong with me? I can't believe I had that wrong this whole time. 62 fifths. So this should be a 62 fifths. I'm so sorry. You know what? It just proves that even the best of us make mistakes. Okay, so if I make these 62 fifths, let's see here. When I do 62 fifths minus 16, now all of a sudden my common denominator is not 4. So I'm not going to use a 4 there. So I'm going to have to multiply that by 5. It'd be 80 fifths. So 16 is 80 fifths. So 62 fifths minus 80 fifths is negative 18 fifths. So let's see. Let's just rewrite this. 4n minus 18 fifths. Okay, now that should work. Okay, I'm so sorry about that. There is my formula. And now if I plug in 2, I get 4 times 2, which is 8. 8 minus 18 fifths. Let's see here. 8 could be read as 40 fifths. That is equal to 8 minus 18 fifths. So 40 minus, I feel like this is still not going to work. Yeah, 22 fifths. Yeah, there we go. So again, I apologize for that error, but now we realize if I plug in 2, I do in fact get 22 fifths. All right, now the only way problems can get a little bit trickier is a situation like this. You are given 2 seemingly random terms, right? So imagine that if we tell you that this is linear or arithmetic, now it means the same thing, right? The only difference is that you can only plug whole numbers into an arithmetic sequence, but it's still linear. So imagine if I tell you that 2 of the inputs, outputs are 5, 8, 15, 12. Now this is writing them in like XY format. This would be writing them in function format. Plug in 5, you get 8. Plug in 15, you get 12. And this is writing them as a sequence, right? I'm just trying to get you guys to realize it's just a different way of writing a function. The 5th term is 8. The 15th term is 12. Okay, input 5, output 8, input 15, output 12. So now if I said, all right, write a formula to find any term, the problem is that they're not consecutive. So the first issue I have to figure out is what is the common difference? Well, remember, the common difference is our constant rate of change. Constant rate of change is the slope in our linear function. So basically, if I find the slope, that is the same thing as the difference. It's my constant rate of change. So if I subtract the y's on top, 12 minus 8, subtract the x's on the bottom, 15 minus 5, I will get that common rate of change or that common difference. So 12 minus 8 is 4. I got to be careful with my work now. I made that mistake. 15 minus 5 is 10. So there is my rate of change. It's going to be up 2 fifths, up 2 fifths, up 2 fifths, up 2 fifths. And 2 fifths is a terminating decimal, so I would not mark you wrong if you put a 0.4 there as my common difference. So I just have to recognize that, yes, I'm not given, all of the sequence. I'm not given the first 5 terms. I'm not given successive terms. I'm simply given 2 random terms, the 5th term and the 15th term. Now, I think that's a pretty cool way to find difference, but I do want to show you one other way that you could use, but hopefully that makes complete sense. But I want to show you one more way. What we could do is we could just think, okay, if I am the 15th term, or let's start the 12th term. If I'm the 12th term and I want to get, let me start over. Boy, this is, I've had better days. All right, if I'm the 5th term, right here, and I want to get to the 15th term, I would need to add 10 differences, right? Think about that for a second. If I'm at the 5th term, and I know that there's a common difference, because I know I'm arithmetic, I know I'm linear, then I would need to add 10 differences to get to the 6th, the 7th, the 8th, the 9th, the 10th, the 11th, the 12th, the 13th, the 14th, the 15th. It would take 10 differences to get to the 15th term. So again, if I don't know the common difference, this is a nice way that I could solve for it. So now the 5th term is 8. I can literally turn that into an 8. The 15th term is 12. I can literally turn that into a 12. And then I can simply solve. Subtract the 8. 10d equals 4. Divide by 10, and I get 4/10, which reduces to 2 fifths, which is exactly equal to 0.4. So notice I still get the same answer, just a slightly different way of doing it. So instead of finding the rate of change between the 2 points, I just think about, all right, I know the 5th term, and to get from the 5th to the 15th term, I would need to add 10 differences, and then you could fill in the blanks and solve for your common difference. But regardless, once I'm at that point, I'm ready to go. Now remember, what else do I need? I need a single point. I have 2 of them. Could use either one. I'm going to use this one right here, 5, 8, input 5, output 8. So a formula to find the nth term is going to be the output 8 plus the common difference of 0.4 times n minus 5. And keep in mind, please, that the 5 is the term that got me to the term value of 8. Okay, then all I got to do is do a little bit of cleanup work here. So multiply, I get 0.4 times n minus 0.4 times 5 is 2. Combine like terms, and I get 0.4n plus 6. So there is a formula to find any term I want. Feel free to try it out. Plug in 15. 0.4 times 15 plus 6 is 12. Yeah, it worked. Input was 15. Output was 12. So again, the objective here is to find that formula for the nth term. And hopefully I've done a decent job, other than that one mistake. That's just a typo of how to do that. It's not overly difficult. And again, why is it not too hard? Because it's linear, and we know and love how to work with linear functions. And an arithmetic sequence is no different than an arithmetic function. The only difference is the domain. I'm only allowed to plug in whole numbers starting at 1. All right, that's it for arithmetic sequences. Hope you enjoyed it.